Since you've already watched the practical wiring video, you've seen that this is the trainer that I've wired up the Copeland CoreSense controller on. I wanted to give you a little more detail about the electrical trainer that it's on and the actual controller and some information that you will need to do the quiz. Here's a trainer. I don't have anything wired on it right now, but this is a trainer you would have been very familiar with if we were doing in-person classes, because you would be using it pretty much every night. You can see that there's a handoff auto switch and on-off switch. And important for this is the speed control dial. And those wire to this terminal strip here. And you can see how the diagram for the handoff auto, the on-off switch, and then the potentiometer. The potentiometer is a 10,000 ohm potentiometer, so that I can dial that dial from 0 to 10 and create a resistance that ranges from 0 to 10,000 ohms. That's kind of important for the test we're going to do with the CoreSense controller. There is the power service disconnect coming in, 24 volt transformer. Here, a contactor and a motor starter. The difference between a contactor and a motor starter is that the motor starter has an overload relay, and that is that part right there. They have auxiliary switches. You can see to the terminal strip there. There's auxiliary switches mounted on the side, and for the overload, there's also a normally open and normally closed contact. Here is the terminal strip with that we would use if needed, and here's the relays. The first relay on the left is a 110 volt 3-pole relay. There's a 110 volt single pole relay next to it to the right, and going over to the right, there's two 24 volt relays. One is a double pole double throw, and the other is a single pole double throw 24 volt relay. On the bottom of the board, we'll start back over here on the left. There's a red push button and a green push button. Those are normally, those are momentary contact push buttons. And when you look at the terminal strip here that they're wired to, the red one is a normally closed and the green one is a normally open. We would use that for a stop start station. And there's a couple toggle switches. There's a single pole, single throw toggle switch. And then down here on the bottom is a double pole, double throw toggle switch. And it's wired out to these terminal connections here. Over here on the right hand side of the bottom, that's a train VAV controller. It is what they call an analog electric. It has the 4 potentiometers. You can see there R68, 69, 67, and R8. And that's how you set up the VAV controller. We have a VAV box. We would mount this to the VAV box, put a fan, controls a damper actuator like that, pressure transducer, and a thermostat. And we also have the option of using a thermistor for duct temperature. So that should give you a little better idea of what the electrical trainer looks like. When you look at the one I've got wired here, kind of looks like a mess, wires going everywhere, but we try and do our wiring to learn the practical aspects of the wiring and follow the wiring diagram. It doesn't always look the neatest, but you know, if we were building a control panel where this was going to be in a unit, we would run wire tray, and we would make sure all the wires follow in a neat, orderly fashion. But right now you can see on the CoreSense controller, the green light is on. I have the power on. Obviously there's 24 volts getting to T1 and T2. That's why the green light is on. Right now I have the cooling controller off, which is the rotary switch there, and the contactor up here is de-energized. I'm going to go ahead and turn on the cooling controller. And I'm sure you heard and you probably saw that the contactor did energize The green light is on. Everything looks to be fine. Now, if you look at the small red, black, and blue wires, I've got those wired up here to the potentiometer. And you'll see between the blue and black, I've got a fixed resistor, and that is for the scroll temperature. I've got a fixed resistor that keeps the scroll temperature at a normal temperature. But you can see between the red and the blue wires, that's tied to the potentiometer. And now as I rotate the potentiometer to change that resistance, and again, I can change it up to 10,000 ohms, and I get to a certain point here, and you hear the contactor drop out. You saw the red light start flashing, and you see the red light is flashing one time. That's because the resistance that I've shown between the red and the blue wires, which is the motor temperature sensor, the positive temperature coefficient motor temperature sensor that you put on your drawing right here, that is no longer in the range that it needs to be. Now, I think I mentioned this in the first video. If I was to just turn this resistance back down to something that would be normal for the motor temperature sensor, it would eventually reset. In 30 minutes, it'll reset. But if you have a motor temperature failure, a sensor failure, and the light is flashing, you can always cycle power. Let the core sense controller reinitiate. I've still got the rotary switch turned on. After it goes through a little initiation period, you hear the contactor pull back in. So I just reset the controller. There's other things that you can do to create a fault. There's actually several faults, and those will be questions on the quiz. So red to blue here is the potentiometer that I've got connected here, and that is simulating the positive temperature coefficient temperature sensor here. The scroll temperature sensor is a fixed resistor that is between black and blue. You can see right there. And there's the core sense controller. Here are the three wires that would be tied to the motor terminals, because this core sense controller would actually be in that terminal box of the compressor.